Throughout my time as a software developer, I've typed on a number of different keyboards, each of them different in their own unique way. One thing that most of these keyboards have in common, however, is caps lock, which almost always ends up being one of my most used keys. This wasn't always the case, however. In fact, I think that the default caps lock key found on most keyboards is perhaps the worst key ever made. Let me explain why. The first reason why I think the caps lock key is the worst is the fact that it's redundant. When it comes to typing out uppercase letters, the same behavior can be achieved by using the shift modifier, which provides a couple of benefits over using caps lock. For starters, the caps lock function doesn't work on either the number or symbol keys. Each of these require the use of the shift modifier in order to print out their secondary codes. Additionally, because the shift key needs to be pressed in conjunction with another key, it provides real-time physical feedback that the modifier is active. This is in contrast to the caps lock key, which either enables or disables its modifier through the use of a single key press. Because of this toggling behavior, it can sometimes be difficult to know whether or not the caps lock key is enabled, especially when the keystrokes aren't displayed, such as when entering a password or when using Vim motions. Some keyboards do show a caps lock indicator. However, in order to see if this is lit up, you have to look at the keyboard itself, which, ironically, is one of the things you're taught not to do when learning to type. Now, to be fair, some operating systems, such as Windows and macOS, will display an indicator when caps lock is enabled, but it doesn't appear for every application, especially not the ones that I use. Additionally, there's no built-in solution when it comes to Linux, although there are a couple of shell extensions out there. However, personally, I haven't found these to be the best. Ultimately for myself, this makes on-screen indicators unreliable, which means that whenever caps lock is accidentally activated, it's pretty much guaranteed to interrupt my workflow, at least until I figured out what's happened. In fact, because of where the caps lock key is placed, accidental activations are pretty commonplace. This positioning is actually another issue I have with caps lock, as it's located on the home row next to the A key. When it comes to keyboard layouts, this is prime real estate, especially when you consider how infrequently caps lock is used. In fact, if we compare the position of the caps lock key to the position of the return key, which is used far more often, we can see that the caps lock key is actually better placed, sitting only one key away from reach, whereas the return key is two. So how did the worst keyboard key ever end up becoming one of my most useful ones? Well, it all began back in 2016, back when I was a Vim user who also happened to use Apple laptops. At the end of that year, Apple released a new version of its MacBook lineup, the 2016 MacBook Pro, which came with the infamous Touch Bar. For some reason, the company that I had previously thought made the best laptops in the world had decided that pro users would prefer to use emojis instead of physical function keys. Whilst this was bad enough in itself, they also did something even more egregious. They removed the physical escape key. As a Vim user with a MacBook, this was pretty devastating. The lack of physical feedback from pressing the escape key made Vim pretty much unusable. If you're unaware, when it comes to Vim, the escape key is used to switch from insert mode, which is the mode where you're inserting text, into normal mode, which is the mode you mainly use for navigation. This makes the escape key pretty important if you happen to use Vim. So I had to adapt, or heaven forbid, use VS Code. Fortunately, I didn't have to take any extreme steps, as macOS provides a workaround through the modifier keys of the Settings app. This setting allows you to rebind the caps lock key into a different modifier, and so I decided to rebind it to be my missing escape key. This change not only solved my initial issue, but it also improved my workflow, as the escape key was now in a much better position for my fingers to tap. This got me thinking, what else could I use the caps lock key for? So I decided to do some research, and in doing so, I came across the mod tap behavior. This is where a key has different behaviors depending on whether you tap it or hold it for a period of time. This felt pretty perfect, as I could continue using the tap behavior for the escape key, whilst using the hold behavior to act as left control. By doing so, it makes the control modifier much easier for me to reach. And given how often I use the control key both in NeoVim and the terminal, having this set up makes me much more efficient. Overall, this behavior makes caps lock one of my most useful keys, so much so that I now set it up on every keyboard that I use. But you may be wondering how I do so. Well, there's a number of different ways you can do this depending on the keyboard that you're using. Take, for example, the Keychron V10 Max, which I have a review on coming out very soon. One of the big perks of this keyboard is that it uses the QMK firmware under the hood. This makes it incredibly easy to modify the key bindings of the keyboard, and the documentation gives good examples of how to do this for the mod tap behavior. However, what about keyboards that you can't change the firmware on, such as with a laptop? In this case, there are software options available, with different ones depending on which operating system that you're using. When it comes to macOS, my preferred app has typically been Carabiner Elements, which has a number of different community implementations of this caps lock key behavior. I've put a link to one that I used to use in the description down below. When it comes to Linux, the tool I used to use was Caps to Escape, which is a plugin for a larger interception tools package. This is typically available in most package managers and was always simple to install and enable. Recently, however, I've added more custom key bindings, ones I'll talk about in another video. Because of this, I now use a tool called Kanata, which is a cross-platform software remapper written in Rust, by the way. To install Kanata, you can either use your operating system's package manager or through the use of Cargo using the following command. In my case, I mostly use Kanata with Nix and NixOS. However, let me show you how to set up the caps lock behavior using a standard configuration file. To do so, first create a new file called config.kbd. Kanata uses a Lisp-like syntax for its configuration, and so I can set the file type as follows in order to get syntax highlighting. In order to begin our configuration, the first thing we need to do is define which keys we want Kanata to overwrite. This is done by using the def source function, which takes a list of keys that we want to remap. In our case, this is just the caps lock key, which is defined as caps. When it comes to remapping our keys, the caps key is now defined at index 0 when we eventually call the def layer function. Next, we need to define our custom behavior, which is our mod tap behavior of control and escape. In Kanata, you can either do this directly inside of your def layer call, or you can do it by first mapping the behavior to an alias, using the def alias function. Let's use it to create an alias called escape control, which will have an associated action of tap hold. The tap hold behavior is Kanata's version of mod tap, and requires 4 different values for its configuration. The first 2 parameters of this behavior are the tap timeout and the hold timeout, both of these in milliseconds. The tap timeout is the number of milliseconds within which a rapid press-release press of a key will result in the tap action being held, instead of the hold action activating. This can enable you to still use the key for key repeats if you need to, although this functionality isn't really used when it comes to the escape key. The second of these values is the hold timeout, which is the number of milliseconds it would take for the hold action to be activated. In my case, I like to set both of these values to be 100 milliseconds, which feels pretty good for the caps lock key. The next parameter is the tap action, which in our case we want to set to be the escape key. The last remaining parameter is the hold action, which we want to set to be left control. With that, our escape control alias is now defined, and we can use it within the def layer function to map it to the caps lock key. To do so, we can call the def layer function with the name that we want to give this layer. In my case, I like to set this to be base. After the layer name, we then define the mappings we want to give to our keys in the same order that we defined when we called def source. In our case, we only defined the single key of caps lock, so all we need to do is pass in our escape control alias. With that, our configuration is now defined, and we can use it with Kanata to remap our caps lock key. To do so, all we have to do is call the Kanata binary, passing in the config using the -c flag. Additionally, we also need to use this with sudo, although in Linux you can prevent this requirement by making sure to add the user to the correct groups. With Kanata running, we can see that our keyboard is now sending the correct codes depending on whether we hold or tap the caps lock key. That wraps up the basic Kanata implementation, which we can also use on both macOS and Windows as well. One thing to be aware of, however, is that on macOS, Kanata will overwrite the function row keys. This means you'll need to either explicitly set them in your Kanata config, or instead use Carabiner Elements, which does this by default. If you want to still use Kanata, there's a GitHub issue that can show you how to set up the function row mapping, and I have a repo with further documentation linked down below. Additionally, if you want Kanata to start up whenever you run your machine, then you'll need to add this into your OS's system service. Again, the repo down below will have some instructions on how to achieve this. As I mentioned before, my preferred way of using Caniter is using the Nix package manager, which not only handles setting it up as a service, but also allows me to share this configuration across multiple machines. This comes in handy as my Caniter configuration also has support for home row mods, which really improves my productivity when it comes to working on a laptop. However, that's going to be a video for another time.